Hello, everybody. I hope you have a good time. Today, I want to solve another problem of static. It's about the structures, and this problem is from Statics by Meriam. Here you can find my Telegram and WhatsApp phone number, and also my ID on YouTube. Please subscribe to watch more videos in future. Now, the problem that I'm going to solve it is number 24 of the chapter 4. The loading of problem 4/23 is shown applied to a whole roof truss. Neglect any horizontal reactions at the supports and solve for the forces in all members. Compare with the result of problem 4/23. Now we want to solve this problem with the method of analyzing joints. As you see, this truss is symmetric. When we speak about symmetry, we should say that symmetry is in load or is in dimension, and whenever we speak about symmetry, we should consider both of these kinds of symmetry. We need to truss or a structure should be symmetry in dimension and also in load. When symmetry has these two conditions, when a truss has these two conditions, we can say that the reaction of supports are the same. We can, because in generally these two supports have two reaction in each. This is A of y and A of x, and also we have E of y and E of x. And generally this is a two-dimensional rigid body. You know, in two-dimensional rigid bodies we have three equilibrium equations. The summation of f of x is equal to 0, the summation of f of y is equal to 0, and the summation of moment, for example, over the point of A is equal to 0. And from these three equations we can find only three unknown support reactions. So we cannot find all reactions here. In this equation, as it's mentioned in the problem that we should consider neglect any horizontal reactions. In this equation, we can consider that all loads are divided by two reactions. For example, 2E of y is equal to 5 kilonewtons. So E of y is equal to E of A of y is equal to 5 divided by 2 means 2.5. And E of x is equal to A of x is equal to 0. This equation is from symmetry. And this is from problem. Okay. Now we have to find all forces of members y by one by one, and here I should we want, but the joint that we want to analyze should has only two unknown members about force. So I have to start from A or E. Both of them are the same, but before solving this truss, I should say that we can find some forces of some members now. For example, I can say that the force of BH is equal to 0. Why? Because in H we have three members, and two of them are in one direction. So the third one should be 0, because in this joint, if I write the sigma is the summation of f of y is equal to 0. In this way, we can say that the force of BH is equal to 0. Yes, I can say that this force is 0. This force is 0. But when we can say B of BH is equal to 0, if we didn't have any external forces at that joint here, because we don't have any external forces on H or on F, we can say that here these two members have the force of 0. But for BG we cannot say, because we have 1 kilonewton here and also here. But we can find BH. Or for example, if we write sigma, the summation of f of y for B, we can find BG easily. We start from A. Yes. For joint A, we have external force of A. External force of 2.5, and it's noun. And also we have two unknown forces. For example, AH and AB. When we write AH in this direction, we should consider the reaction force on the member. Here we have and in this condition we consider as compression. And when we consider the force AB in this direction, we should put the reaction of AB here and also here. Why? Because we have equilibrium on members and also on joints. In this condition, this member is under tension. So we have to be careful about this situation. And here A is as a particle, and also we have concurrent forces. In this situation we have only two equations. The summation of f of x is equal to 0, and also the summation of f of y is equal to 0. And this is the point that we have to start from a joint that has only two unknown forces. Because if it had three unknown forces or more, we wouldn't be able to find all unknown forces. And we have to find this angle. In this equation, in triangle of A, C, G, we can write that tangent of alpha is equal to CG divided by AG, means 2 divided by 4. So alpha is equal to inverse tangent means 26.565. 26.565 degrees. Here we have x and y. The summation of x means AH cosine of alpha, or 26.565 minus, excuse me, AB, not AH. This is AH. So minus AH is equal to 0, and in y direction 2.5 plus 2.5 plus AB sine of 26.5, excuse me, 2.5 plus AB sine of 26.565 is equal to 0. From the last one, we can find AB is equal to minus 20.5, excuse me, minus 2.5 sine of 26.565. And here 2.5 divided by sine of 26.565 means minus 5.59 kilonewtons. We have to put this AB to the first equation. AH is equal to AB cosine of 26.565 means AH is equal to minus 5.59 cosine of divided by 5.59 cosine means minus 5. You can see that we consider AH as a compression and we find negative amounts. So we should say AH is equal to 5 kilonewtons tension. And also AB, we consider it tension in this direction, but for AB we find that it's negative. So we should say that AB is equal to 5.59 kN compression. And now we can analyze another member. Here we have zero force here, and because these two members are in one direction, we can say that AH is equal to HG. So we can say that HG is equal to AH is equal to 5 kilonewton tension. But I think we have made a mistake because the answer is different. AB 3 point Y. We should check. Just a moment, please. We should check again. 2.5 divided by sine of 26.565. And AB cosine. Okay, here we made a mistake, and mistake is about external force. We didn't consider 1 kilonewton here. The answer that we found was wrong. Here we have 1 kilonewton, yes, because of this. And this mistake is familiar, and unfortunately I made a mistake. I have to correct the equation in y direction, because this 1 kilonewton acts in y directions. Here we have and this is negative. We have 1.5 negative, so 1.5 divided by sine of 26 point. The answer is 3 point, and here we should correct it. And if I consider AB, I should say that 3.3 3.354 cosine of, and the answer is 3. Yeah, that's okay. Now we have to find another joint. We have to, analyze another joint. Go to B. And in the joint B, we have these two directions. AB is compression, so it acts in this direction, and this is AB. And now BH is equal to 0, BG and 1 kilonewton. First of all, we should consider 1 because of the last mistake. And AB is equal to 3.354. And now I consider BC here and BG here. Means both of them are compression. I consider both of them compression. And if I made a mistake, you can say that we found it in negative amount. This is X, this is Y, and you know this is alpha, and 565, and for this angle is the same, yes. Why? Because this is alpha and this is alpha, so both of them are the same. Again, we have two equilibrium equations, so the summation of f of x is equal to 0 and the summation of f of y is equal to 0. In x direction we have 3.354, excuse me, cosine of, this is alpha, and minus BG and minus BC cosine of is equal to 0. Because 1 kilonewton doesn't have any components in x direction. So in y direction we have 3.354 sine of plus BG sine of minus 1 minus BC sine of is equal to 0. We can so we have to write these equations again. Means plus cosine of 26.565 BC means okay, multiply cosine of 26.565 means 3, and sine of 26.565 PG minus sine of 26.565 BC. So 3.354 sine of 26.565 again sine of 26.565 divided multiply 3.3. Means minus 1. What? Minus 1 means and so we can find the BG here. BG is equal to BC divided by sine of, so means BC minus 3.5 divided by sine of 26.5 means we can put this equation here, so we can say that BC is equal to 3. So we can say BC is equal to 3 plus 3 plus cosine 26 point 565 multiply 1.118 divided by 2 cosine 26.565. So 2 point, and we should put it here, so we have minus 1.1. The answer is here. So we consider these two forces compression, and we find positive magnitudes. The guess that we had is correct, and here we can say that this force is 2.224 because of 6, and BC, because of symmetry, is equal to CD, and compression, and BG is equal to DG. So the only member that remains is CD. So we have to analyze the joint C. And for C, we have C and 1 kilonewton. So 1 kilonewton here. Because it's noun, we use blue color. And BC, for BC we have 2.24, and also CD, because of symmetry we have the same magnitude of BC here, and the only unknown member is CG, so we consider it compression, CD. Okay, the only equation that we need is summation of f of y is equal to 0 cd plus 2 divided by, and in this triangle this is 26.565, so this is so we can say sine of 26.565, because this is 26 point, and minus 1 is equal to 0. CD is equal to 1 kilonewton. CG is 1 kilonewton. We should check again. BC we found BC as excuse me, I made a mistake. CD plus, okay. Again, minus 2 multiply sine of 26 divided multiply 2.24. The answer is minus 1 kilonewton. We consider it compression, but we found negative, means it's tension. Yes, the answer is tension. So CD is equal to 1 kilonewton tension. That's it. We could find all forces about all members, and that's it. Have a good time. See you in another problem. Bye.